complete examples 1 and 2 from notes 3.3, in which we're going to learn about long and synthetic division. These techniques will help us to find zeros of polynomials when we can't easily factor them. But before we get to those techniques, we're going to go back to, say, when you were in 4th grade, maybe 3rd grade, and you learned how to do long division. So we're going to try to divide 8497 by 51 by hand. So in order to do that, the technique that you learned was you're going to make like a little house. Outside of the house, you're going to put the number 51. And inside the house, you're going to put the number 8497. And you're going to go through the steps of long division. So that means you're going to ask yourself, how many times does the number 51 go into 84? You're going to answer your own question, and you're going to say, oh, it goes in 1 time, and you're going to write 1 on the top of the house above the 4 because you're dividing 51 into 84. The next step is you're going to multiply. 1 times 51 is 51, and then you're going to subtract 51 from 84, and when you do the subtraction, you're going to get 33. Next step is you're going to bring down the 9, and then you're going to ask yourself a similar question. You're going to say, how many times does 51 go into 339? It goes in 6 times, so you're going to write 6 up above, and then you're going to go ahead and multiply. So you're going to multiply 6 by 51. That gives you 306. And then you're going to subtract. 339 minus 306 is going to give you 33. And then once again, you're going to bring down the 7, ones digit, and then you're going to ask yourself, how many times does 51 go into 337? That is once again going to be 6. You're going to write 6 up at the top. You're going to multiply 6 times 51. That's going to give 306. Try to fix that 3. And then you'll subtract once again. Subtracting this, you're going to get 31. We call the 31, if you remember down here, this is the remainder, is 31. So we have 2 choices. We can write 166, and then up here we can write remainder 31. That's how you first learned how to do it. And then later you learned that you could write 166 and you could put the remainder 31 over 51. And that could be your answer as well. I also want to review some of the terminology. So the number that we divide by, this number over here, this is called the divisor. The number that we divide into, circle that, this 8497, that's called the dividend. And the answer that we get, this whole number answer part, this is called the quotient. And we've already mentioned that 31 is the remainder. Now we're going to go on and we're going to try example 2. In example 2, we're going to apply the technique that we use for long division with numbers to a polynomial. And you can see on the right-hand side I have the steps noted, but I don't want you to read that right now. I'd just like you to follow along with me in this procedure. So we're going to do the same thing we did when we had numbers, when we were dividing. And we're going to go ahead and make the little house. Underneath the house, we're going to put the dividend, which is x cubed plus 4x squared minus x minus 1. And on the outside, we're going to put the divisor, which is what we're dividing by. So we're going to divide by x plus 3. When we do long division, we're going to focus on this highest power term. When we ask ourselves, how many times does the divisor go into the dividend? So here we're going to say, how many times does x go into our highest power term, which is x cubed? How many times does x go into x cubed? That would be x squared times. And we're going to write that above the like term, the corresponding term. And then once we answer that question, we're going to multiply. So we're going to say x squared times x is going to give us x cubed, and x squared times 3 is going to give us plus 3x squared. And we're going to write that as we did when we were dividing with numbers. And then we're going to subtract. So I'm going to put a subtraction, and I'm going to put parentheses here so we remember that we're subtracting. So I'm going to do 4x squared minus 3x squared. That's going to give me x squared. And x cubed minus x cubed gives me 0x cubed. I don't need to write that. Then we're going to bring down the next term. So we're going to bring down a minus x. And then we're going to ask ourselves again, how many times does x go into x squared? And we're going to answer that. The answer is x, because x times x is x squared. So I'm going to write plus x as we define our quotient here. And now we're going to multiply. So we're going to say x times x is x squared. X times positive 3 is plus 3x. And then remember, we're going to subtract those two polynomial expressions. So we're going to have negative x minus 3x is going to give us minus 4x. And x squared minus x squared is going to give us 0x squared. I'm not going to write that. And then I'm going to bring down the minus 1. I'm going to ask myself again, how many times does x go into negative 4x? That would be negative 4 times. And then I'm going to multiply. So negative 4 times x is negative 4x. And then negative 4 times 3 is minus 12, or negative 12. And then, once again, I'm going to subtract. So I'm going to have negative 4x minus negative 4x is going to be 0x. Negative 1 minus negative 12 is like negative 1 plus 12 will be plus 11. There's nothing left to bring down. So 11 is our remainder. So I could go ahead and write this as remainder 11. But normally, when dividing polynomials, we're going to write it as plus 11, the remainder, over the divisor, x plus 3. And this right here is our answer, x squared plus x minus 4 plus 11 over x plus 3. That's the answer when x cubed plus 4x squared minus x minus 1 is divided by x plus 3.